Hello guys, so this is the video from section 12.7. It will be our last video for this semester. So, paper. Okay, so that will be section 12.7. Okay, so I will be going back and forth between PowerPoint and the notes. So first, let me show you the PowerPoint of section 12.7. Okay, so 12.7 is about solving system of inequalities. So we're going to solve them a little similar like system of equations, but when we're solving systems of inequalities, the solution of the system will be infinitely many points. So we're going to represent the solution using the shaded region. Like similar like when we were graphing inequalities. Now we're going to have two or more inequalities combined together, which we call system. So 12.7, we're going to solve linear inequalities. We're going to solve inequalities having circles and parabolas. I'm going to teach you how to graph system of inequalities, and we'll go over one of the word problem. So that's what we have in section 12.7. So let's talk about graphing inequality. Okay, so here is the difference, and I really want you to guys focus on the slide number 4. Here on the first graph, what you guys see, you see the straight line 3x plus y equals 6. So we know how to graph the straight line. Again, you can just solve for y. So that is y equal negative 3x plus 6. And you can use the slope y-intercept form, which means slope is equal negative 3 over 1. Y-intercept, it's equal 6. So you have 0.0 comma 6. So this is our y-intercept right here. And the slope is equal negative 3, which means to find another point, we'll go 3 units down, 1, 2, 3, 1 to the right. And you will continue. 3 units down, 1, 2, 3, and 1 to the right. Okay? And we're connecting. That's how we end up with the equation of graph of 3x plus y equals 6. Now, graph B shows you how to graph inequality 3x plus y is less than equal 6. So how are you going to graph that? Okay, so first you always graph the straight line 3x plus y equals 6. And we already graphed that. So this is that straight line which you guys see it. Okay. And now a couple things. When you have inequality and equal sign, all the points on the straight line are the solutions of the inequality. So we including that straight line. If you will only have a strict inequality, we will use the dashed line. Okay. And now look what happened. You have 3x plus y is less than equals 6. So usually the rule is that when you have a less than, you're shading everything to the left. Okay, so that's why they shade everything to the left of that straight line. And if you will have opposite, and if you will have the 3x plus y greater or equal 6, we'll shade everything to the right. But if we're not sure which part of we should shade it, left side or the right side, what you can do, you can always pick a point. I will pick this one because this is easy. 0, 0. Okay, I'm really sure that we should shade everything to the left from the straight line because of the less sign, and usually that's how it works, but I just want to double check. So this point 0, comma 0 should be part of the solution. Let's check if that works. Let's replace x with 0, y with 0, and plugging it into that inequality. So we have 3 times 0 plus 0 less than equals 6. We end up with 0 less than equals 6. This is true. So I'm pretty sure that we have to shade everything to the left, okay, which is the blue region. Like you see, on the right side, you see 2 points. Let's check this point, 5, comma 5. This is x, this is y. If you were plugging in those coordinates into the inequality, so we'll have 3 times 5 plus 5 less than equals 6. We'll end up with 20 less than equals 6. Like you guys see, this is false. So that already tells you that you should not shade the right side of the graph from the straight line, okay? So here, everything what I explained it, here you guys have steps for graphing in inequality. So step 1, we have to replace inequality symbol by the equal sign and graph the equation. So we're graphing straight line, maybe we'll be graphing circles. If the inequality is strict, so this is important, use dashed line. If the inequality is non-strict, which means has that equal sign, you will use the solid mark. This graph separates the xy planes into 2 or more regions. Now, in each region, this is step 2, select a test point P. If the coordinates of the point satisfy inequality, so do all the points in that region. Indicate this by the shading the region. If the coordinates of points do not satisfy the inequality, so you end up with something what is false, none of the points is in that region. So those steps, like you guys, so right here, we supposed to graph the inequality 3x plus y less than equals 6. I started with graphing the straight line, which is 3x plus y equals 6, right here. And then you see that my straight line has a solid line because my inequality is not strict, which means has that equal sign. And now the solution of this inequality, it's either going to be region on the left side or on the right side. Usually, again, I can tell you, you see less than, so everything to the left. You will see greater than, everything to the right. But you always want to pick a point. So that's what I did with the point 0, comma 0. I was 99% sure that this is the region which we need to shade it. But double check, make sure that you will plug in those coordinates into the inequality, and you will end up with something true. Since 0, comma 0 gave me true statement, that means all the points on the left side from the straight line are the solutions. Now, I also shows you that that I test point 5, comma 5, and when I plug those coordinates into inequality, I end up with something false. That means every single point on the right side from the straight line, 1, it's not the solution. Okay? So next problem, I'm going to slowly do it with you guys. We're going to graph the inequality Okay, let me just put that. We're going to graph okay, hold on. Just put it on top. Okay, so we're going to graph x squared plus y squared less than equal 4. So first, we're going to graph x squared plus y squared equal 4 hopefully you guys recognize that this is circle. The equation of the circle was x minus h squared plus y minus k squared equal radius squared. So h, k are the center. Since we don't have parentheses, so the center will be point 0, comma 0. Radius squared is equal 4, which means radius is equal 2. So we have a circle with center 0, comma 0, and radius of 2. So let me graph it. Okay, so this is one. So we have center 0, comma 0, radius is 2, so 2, that will be one of the point. Second point of the circle, third one, and fourth one. So now look what happened. Because we have less than and equal sign, so what that means, that that the circumference of my circle is part of the solution. Okay, if that would be just inequality, we'll have a dashed line. And now this is what happened. Okay, you have x squared plus y squared less than equal 4. So you have two choices. Our solution will be all the points inside the circle, including the circumference, or our solution will be all the points outside of that circle. So entire region outside of the circle. Okay. So now you have to figure out which region is our solution. So I told you guys that usually, when you have less than, so that will be inside, and if that will be greater than, that will be outside. But you want to check. So I'm going to test. So again, I'm pretty sure that the solution will be circumference of the circle and all the points inside of the circle. So I want to test the point P, which has coordinate 0, comma 0. And what I'm going to do with that point, I'm going to plug in into the equation. X squared plus y squared less than equal 4. We're going to replace x with 0, y with 0, and we're checking if we're getting true statement. So we're having 0 is less or equal 4, 0 is less than 4, so this is true statement. So that means point P, which is inside of the circle, and all other points inside of the circle, it's part of our solution. Okay, so this is the solution. And don't forget that since we had inequality and equal sign, we may not see it. I'm trying to mark that on yellow. So that means also the circumference of the circle. It's part of the solution. Okay. So that was the first problem. Okay. Okay, just give me a second. Trying to figure out what happened. Why the PowerPoint doesn't work. Okay, let me pause the video and figure out what's happening with PowerPoint. Okay, so next what we're going to do, we're going to graph more inequalities. So that will be example 2. So I want you to graph, going to graph linear inequalities. So the first one, we have y less than 2. So first what you want to do, you want to graph the straight line y equal 2, which is horizontal line. Okay, so let's graph. So y equal 2. And now look what happened. You have a strict inequality. That means you will have a dashed line. This is y equal 2. And again, so that means the straight line y equal 2, it's not part of the solution. So the solution will be either the region which is below, or the solution will be region which is above the horizontal line. Okay, so now we need to do the test. I mentioned to you guys that less than, that means most likely the region below the straight line, but just double check. Let me pick the point again, 0, 0. So I'm going to test 0, 0, and I'm going to plug in that into the inequality y less than 2. Okay, so this is x, this is y. So we have 0 less than 2. This is definitely true. So what that means? That means that entire region below the horizontal line is the solution of this inequality. So don't forget that you guys graphing on my MATLAB. So it's going to be a tool, you're going to see like a bucket or look like a paint. And that's what you will need to use to shade the correct region. Okay. So that was A. We're going to do one more problem, very similar to this one. Y greater equal 2x. Okay, so that would be B. Y greater equal 2x. So first what we want to do, we want to graph y equal 2x. So this is the straight line. And again, because we have equal sign, you will use the solid line. So to graph y is equal to 2x, so this is the same as y equal 2x plus 0. So I know the slope is 2 over 1, and 0 is the y-intercept. Zero equal y-intercept. Okay, so let's just graph it. Okay, so y-intercept right here, slope it's 2 over 1. So 2 up, 1 to the right. That's my next point. 2 up, 1 to the right. Next point. Or we can go 2 down, 1 to the left. 2 down, 1 to the left. Okay, and I'm using the solid line because we have, again, inequality with equal sign. So let's connect all those points. Okay. Right here. So this is part of the solution, and now we have two choices. Either we will shade everything to the left, or we will shade everything to the right of that straight line. So greater than 2x, so I'm assuming that it's going to be everything to the right side. So I'm going to pick nice point, which is on the right side. This point has coordinates 1, 0, and let's just test if this point satisfies our inequality. So 0.1, 0, the inequality is y greater equal 2x. So we having 0 is greater equal 2 times 1. So 0 is greater equal 0 is greater equal 2. This is not true. Okay. 1, 0, y greater equal. So now we have 0 is greater equal 2. This is false. Okay. So that means we will shade 1, 0, it's not part of the solution. So we're going to shade everything to the left. Okay. And again, if you want to double check, okay, if you want to test point -1 comma 0, so then -1 comma 0, so this is x, this is y, so we're having y, which is 0 greater equal 2 times -1, and then we're having 0 is greater equal -2, and this is true. That's why we shade everything to the left. So again, just be careful. Don't assume all the time that greater means everything to the right side. Now let's go back to our PowerPoint. Okay. So we solved those two problems from your PowerPoint. And now we're going to talk about graph and system of inequalities. So what happened, we're going to have two, sometimes more, inequalities together, and we're going to graph it, and point region of intersection will be the solution. Okay. So here we're going to work with the first example when we have to graph x plus y greater or equal to 2x minus y less than equal 4, and we need to find the solution. So don't forget that when we're solving system of inequalities, solution is the region of intersection, not the point of intersection. So example 3, that will be example 3. So we have system of inequalities, x plus y greater or equal to 2x minus y less than equal 4. Okay, so this is system of inequalities. You have inequality 1 and inequality 2. How are you going to do it? So first, we're going to graph inequality 1. Okay, so let's just graph that in blue. So we're going to graph x plus y greater equal to. So we know how to graph that. You want to first graph x plus y equal to. Okay, so let's solve that for y. So this is y equal negative x plus 2. Okay, and this is straight line. So slope, it's equal -1. Y-intercept is 0, comma 2. Okay, so I have 1 point. And I'm going to find you can find the second point using the slope, which is equal -1. Or if you want to, you can just replace, let's say, x with 1, and y will be equal -1 plus 2, which is +1. Okay, so let me graph the first inequality. Okay, so I have point 0, comma 2 and 1, comma 1. Again, slope was -1, so that's why you're going 1 down, 1 to the right. Okay, now look what happened with our first inequality. We have inequality and equal sign. Okay, so that means that straight line, you can find more points using slope equal -1 if you want to. So we including the straight line as a part of the solution. Okay, and now we have to focus on which region we're going to shade it, below or above. So we have greater than. Again, I'm thinking that we will shade everything what is above. So let me test the point 1, comma 3. Okay, this point 1, comma 3. So I'm going to test point 1, comma 3. Let's plug that into our first inequality. So we have 1 plus 3 should be greater equal to. We're having 4 greater equal to. This is true. Okay, so that's why the solution, it's the region which is above the line x plus y equal 2. And of course, we including the line x plus y equal 2 as a part of the solution. So this is first inequality. Okay. Now look what's going to happen next. Next, change that to orange. Next, what we're going to do, we're going to graph the second inequality on the same xy plane. So second, graph 2x minus y less than equal 4 on the same xy plane. Okay, so we need to graph that 2x minus y less than equal 4. So the same idea. First, you want to graph 2x minus y, replace inequality with equal sign, equal 4. That's the straight line. So also let's solve for y. So I will add y to both sides. So we're having 2x, it's equal y plus 4, and subtract 4 from both sides. So we're having y, it's equal 2x minus 4. So we need to graph the straight line. Slope, it's 2 over 1. And y-intercept, it's 0, comma negative 4. And I'm going to graph the second inequality using orange color. So we have 0, comma negative 4. 1, 2, 3, 4. So this is the y-intercept. Slope, it's 2 over 1. So I'm going 2 units up, 1 to the right, 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 and so on. Or you can go 2 down and 1 to the left, 2 down and 1 to the left. Okay, the same idea, because we have inequality and equal sign, so you're going to have a solid line. And now we have two solutions. From that orange line, you're going to shade the region on the left, to the left of the orange line, or to the right of the orange line. So I have less than, less than. Okay, so again, maybe that will be region to the left. So let's just test the point 0, comma 0. Because that's easy to test. So I'm going to test 0, comma 0, xy. Let's plug in into our inequality. So that will be 2 times 0 minus 0 should be less than equal 4. So we're having 0 is less than equal 4. This is true. Okay, 0 is less than equal 4. This is true. So that means every single point to the left of the orange line, it's the solution of the second inequality. So I'm shading entire region to the left. And now, what is the solution of system of linear inequalities? So the solution is, and right now here you guys see it, is the region where two graphs intersect. So it's going, the solution of this inequality is going to be the green right here. Here, this is the solution. Is the region where those two linear inequalities, those two regions intersect. So this is the solution, that region right here. Okay, everything what we have in green. Okay, right here. Sorry, I cannot change it for some reason. Oops. So right here, everything what is in the green. Okay, so that's the solution. So let's go back to the PowerPoint. Oops. Sorry. So here also on the PowerPoint, you guys have this problem solved, and you see we end up with the same region. Okay, next example. Graph the system. So again, I will leave that for you guys. You can practice. There is a solution. Okay. So what happened with this system, I will just quickly briefly explain it. You guys want to read the solution of the PowerPoint. You have x plus y less than equal 4, x plus y greater equal 0. So those the straight lines x plus y equal 2, x plus y equals 0, they are parallel to each other. So this is what happened in the solution. Like you see, you have two parallel lines, and the region where two graphs overlap, it's the one right here between those two parallel lines. Okay, so we have also infinitely many solutions. So every single point right here is the solution. Okay. What just happened? Okay, downloads. Okay, so we're going to move on to a little different type of problems. Okay, so here they still graphing straight lines. So I will just leave that for you. I want to start talking about graphing different. Maybe let's solve B together. Let's not skip it. I'm going to solve this one with you guys. Okay? Before we move on to something different. Okay? So we'll go to the through this example. X plus 2y less than equal to. So next example. Next example. We have x plus 2y less than equal to, and x plus 2y greater equals x. So we need to find the region where those two linear inequalities intersect. So the first one we'll graph in blue, and the second one we'll graph in green. Okay, so inequality 1. Okay, so we have x plus 2y less than equal to. So let's start with graphing straight line x plus 2y is equal to. Okay, so we have 2y is equal negative x plus 2, divide each by 2, divide each by 2, and we're getting y is equal negative 1/2 x plus 1. So I will graph the straight line, slope is equal negative 1/2, y-intercept equals 0, 1. So here, the first inequality, because we have inequality and equal sign, so that straight line which we're going to graph, okay, it's going to be solid. Okay, so let's just graph this one. So we have point 0, 1, y-intercept, slope, it's, I mentioned I will graph that in blue. So 0, 1. So the slope it's negative 1/2, 1 down, 2 to the right, 1 down, 2 to the right, or you can do the opposite, 1 up, 2 to the left, 1 up, 2 to the left. Okay, so let me just connect those points. Solid line, and the solution, the region which I'm going to shade it, it's going to be either below or above the line. So I have less than, so I'm assuming that will be the region which is below the straight line, but let me just test the point 0, comma 0. So I'm going to test here, test 0, comma 0. So we're having 0 plus 2 times 0 is less than equal to, we end up with 0, which is less than equal to, since this is true statement, okay? That means point 0, comma 0, it's the solution, or and every single point which is below the blue line. So we're going to shade it, everything what is below. And of course, we're including the straight line. So I'm graphing that by hand. Don't forget that you guys will use the my MATLAB for graphing. And graphing inequalities, it's not bad on the computer. You're just going to use the bucket to shade that region. Okay, next what we're going to do, I'm going to graph the inequality x plus 2y greater or equals 6. So x plus 2y greater or equals 6. So what we're going to do here, just separate them. So we're going to solve, first we're going to graph x plus 2y equals 6. Let's solve that for y. So we have 2y, it's equal negative x plus 6. Divide everything by 2. And we having that y is equal negative 1/2 x plus 3. So here also we will graph the solid line because we have inequality and equal sign. Slope is equal negative 1/2. Y-intercept, it's 0.0, comma 3. So I'm going to use the green color for graphing this inequality. Let's start with y-intercept 0, comma 3, right here. And slope it's negative 1/2. So I'm going 1 down, 2 to the right, 1 down, 2 to the right, 1 down, 2 to the right, 1 down, 2 to the right. Or 1 up and 2 to the left, 1 up, 2 to the left, 1 up, 2 to the left. Okay, so this is the graph. This is the graph of the straight line x plus 2y equals 6. However, we need to graph it inequality greater equals 6. Since I have a greater than, I'm assuming that we'll shade everything what is above. But let me just double check. Okay, so let me test the point which is above. It will be nice and easy to test this point, which is 0, comma 1, 2, 3, 4. So let's just test that point. Test 0, comma 4. So let's plug that into the inequality. So we have 0 plus 2 times 4 greater equals 6. And we end up with 8 greater equals 6. Since this is true, that means this point and all the points above the green light are the part of the solution of the second inequality. Now, since we're talking about system of linear inequalities, so the solution of linear inequalities is the region where two graphs intersect. So look what happened in our case. Those inequalities don't intersect, okay? So those regions don't intersect, so we don't have a solution, okay? So there is no solution. Those two regions don't intersect. The system is inconsistent. So that still can happen that you don't have a solution. No solution. Okay? The regions don't intersect. Okay? So we continue with the problems. And again, here you have figure 20, which shows you the same problem which we just solved. Okay. Next, what I want to talk about this example because it's a little different. Excuse me. The first equation, y greater equal x squared minus 4, it's going to be inequality, which equation y equal x squared minus 4, it's a parabola, and x plus y equal 2, that is the equation of a straight line. So we need to graph the regions below. So we're going to do that. And below x plus y equal 2, and above the graph y equal x squared minus 4, and label all points of intersection. So let's solve this problem. So next example. So we have inequality y greater equal x squared minus 4 and x plus y less than equal to. So I'll always label them inequality 1, inequality 2. Let's focus on inequality 1, which is y greater equal x squared minus 4. So you want to graph it y equal x squared minus 4. This is the parabola, which has a shape U. Okay, so let's just find a couple points. When x is equal 0, y will be equal 0 squared minus 4. So we have a point 0 comma negative 4. Okay, the second point, what we can do, let's make x equal 1. So y will be equal 1 squared minus 4. So we have a point 1 comma negative 3. And maybe let's just find one more. When x equal negative 1, y will be equal negative 1 squared minus 4. So we have point negative 1 comma negative 3. Okay. So I'm going to graph this parabola using, let's graph it, change that, let's graph that with yellow. Okay, so I'm going to graph the parabola with yellow. Okay, so graphing that with yellow. Maybe right here. Okay, so let's create a coordinate plane. So bad. Okay, and we have a parabola, so we have point 0 comma negative 4, 1, 2, 2, 3, 4. This is the point 0 comma negative 4. Then we have 1 comma negative 3, 1 comma negative 1 comma negative 3 right here. So we have a parabola, and the same scenario because we have inequality and equal sign, so we're going to use the solid shape of the parabola. Okay. Now, next what I'm going to do, in blue, I will graph the second inequality, which is x plus y. So just show work here, maybe separate them. So the second inequality is x plus y less than or equal to, solve for y, so having y less than or equal negative x plus 2. Okay, so we're going to graph the straight line y equal negative x plus 2. So slope equal -1 over 1, y-intercept, it's 0, comma 2. Okay, so we have 0, comma 2. Y-intercept slope, it's -1 over 1, -1 over 1, -1 over 1, -1 over 1, or 1 up, 1 to the left, 1 up, 1 to the left, and so on. Okay, so here in this inequality, the second inequality also has an equal sign, so the straight line, it's part of the solution. Oops, sorry guys, before I will rush it, I forgot to shade the region. Okay, so just give me a second. Okay, so here I didn't finish the first problem. Right here, when we grab the parabola, okay, now we have to shade the region, which is either inside of the parabola, will be the solution of the first inequality, or maybe outside of the parabola. Okay, so we have to figure out. So we have y, it's greater, so that greater always talks to me that most likely it's outside. So I'm going back again, I'm still working with the first one because we need to shade it either the region which will be inside of the parabola or outside. I think it will be outside, so let me just test the point. Let's say this one, like 1, 2, 1, 2, 3, 4, 5, 6, 7. Let me test the point -7, comma 0. Okay, so I'm going to test -7, comma 0. So we will end up with y, it's 0, so 0. So we'll end up with 0 greater equal -7 square minus 4. So we're having 0, it's greater equal 49 minus 4, which is again false. Okay, so since this is false, so that means the solution of the first of that inequality, y greater equal x squared minus 4, it's going to be all the points inside of the parabola. Okay, so that means have to be inside. Okay, now we're working with the second inequality. I grab only straight line, so we have that x plus y less than equal 2. So we have less than equal. So I'm assuming that the region which will shade will be below the straight line, but let me double check. So let's check this point right here. 0, comma 0. Let's check that. So I'm going to test 0, comma 0. So we will end up with 0 plus 0 less than equal 2, and this is true. Since this is true, we're shading entire region which is below the straight line. Okay, so you guys see it on my notes. What is the solution? The solution of the system of linear inequalities is the part of the graph where two regions intersect. So our solution will be this part of the parabola plus this part of the straight line, including all the region inside. Okay, so in this problem, let's just go back. They ask you label all points of intersection. Okay, so we need to label this point A, B, C, D. Okay, so we need to give the coordinates Okay, so this point right here, I can quickly see that that was 2, comma 1, because this point, it belongs to a straight line right here. And we had y-intercept was what? 2, and the slope was 1 down, 1 to the right. 1 down, 1 to the right. Okay. Now I think we will have to find the points of intersection, which is nice. What I'm going to do, I'm going to actually here. Wait, I'm sorry. Label all the points, or sorry guys. Label all points of intersection. So we only have 2 points of intersection. I just want to double check. My graph is not the best one. So we have those 2 points of intersection which they want us to label. If you have a nice graph on my MATLAB, you will be able to see them, that we have coordinates -3, 5 and 2, 0. But I'm going to show you how to find them algebraically, okay? So not this point. So the points of intersection, hold on, is point A and B. So just write this down. Point of intersections . So to find them, and if you cannot label them correctly, so I'm recommended to use algebra. So to find them, solve system of equation. So what that means, right here, our original system of inequalities, we're going to convert to system of equation. So we're going to solve y equal x squared minus 4 and x plus y equal 2, okay? Because those 2 points, they are solution, they belongs of the graph of the parabola and the straight line. So when you will solve the system of equations, you will find the point of intersection. So the best way will be just using substitution. We're going to replace y from the second equation with x squared minus 4. So we have, this is equation 2, this is equation 1. So equation 2, we have x plus, we're going to replace y with x squared minus 4. Okay, let's plug it in right here. So we have x plus x squared minus 4 equal to, okay, let's solve that. So we have x plus x squared minus 4 minus 2 equals 0. So this is x squared plus x minus 6 equals 0. Let's factor this. AC method, A it's equal 1, B it's equal 1, C it's equal -6, A times C it's equal -6. Now I want you to find 2 points which by multiplication is equal -6. The same 2 by addition will give you B, which is 1. And that will be 3 and -2. Okay, so we have x plus 3, x minus 2 equals 0, which means x plus 3 equals 0, x minus 2 equals 0. So we're having x equal -3, x equal 2. Okay, so we have the x coordinates of those 2 points of intersections. We have to find the y coordinate by using that y is equal x squared minus 4. So y is equal x squared minus 4. Let's find that y. Y is equal -3 squared minus 4. So y it's equal 9 minus 4, which is 5. And here we have y it's equal to a second power minus 4, which would be y it's equal 0. So we have 2 points of intersections with coordinates -3, 5 and 2, 0. So that's the points of intersection. So when you have to find the point of intersection, convert inequalities, system of inequalities to system of equation. Replace that inequality with equal sign. So that's points of intersections. -3, 5, 2, 0. -3, 5. -1, here -1, -2, -3, 5 right here. And this is 2, 0. Okay, right here, that's B. Okay, so we're going back. Okay, so that's that problem, points of intersection. We convert inequalities to equations. Okay. Here on the slide, I believe this is 22, it shows you that sometimes when you're solving a system of, again, graphing inequalities, like you can see, you can have different regions, okay? But all the time it's region or there is no solution, which is no region of intersection. Here, I want to solve one more problem with you guys. So we'll just quickly talk about it. I will show graph using the PowerPoint, but this is application of word problems when we can use the system of inequalities to solve it. So we have retired couple can invest up to 25,000. As the financial advisor, you recommend that they place at least 15,000 in treasury bill, yielding 2%, and at most 5,000 in corporate bonds yielding 3%. So let's solve part A. Using X, denote the amount of money invested in treasury, and Y will be the amount invested in corporate bonds. Okay. Write a system of linear inequalities that describe possible amount of each investment. Assume that X and Y are in thousands of dollars. So assuming that X and Y's are in thousands, so that means when you have that 25,000 right here, we're going to just use 25 in our equations. And when you have 15,000, we'll just use 15, okay? So we need to build a graph. I will show you guys graph on the PowerPoint, but we need to build that system of inequalities. So let's start reading from the beginning. So we have a couple who can invest up to 25,000. So first of all, okay, let me just write this down. X, money invested in treasury, Y, money invested in bonds. Okay, so first of all, we're talking about money, right? So you guys have to give the condition when you build the system of linear inequalities that X has to be greater than 0. Because the money which we invest in treasury, of course, it's going to be more. Let's put it this way. More or equal 0. Okay. Now we continue. So here the first sentence tells you that that retired couple can invest up to 25,000. So that means the money which they invest in treasury and in bonds together, so I'm adding them, they can invest up to 25,000. So 25,000 it's maximum, so that means that will be less or equal 25. Okay, and we're using only 25 because they mentioned that X and Y's are in thousand. Okay, so they can invest up to. So 25,000 will be the maximum. So that's going to be my third inequality. Now we continue. As the financial advisor, you recommend that they place at least 15,000 in treasury. So treasury, that's my X. Okay, and we have to translate that. So they can place at least 15,000 in treasury. So that means the minimum will be 15,000. So in treasury, then invest 15,000 or more. Okay, and at most 5,000 in corporation in bonds. So at most 5,000, so maximum 5,000 they can put in bonds. So maximum you will say that Y has to be less or equal 5,000. That's how much they can invest in bonds. And this is the system of inequalities to solve this equation. We have to give all the conditions. Okay, so here you guys have the same scenario which I just explained it. So don't forget that we had to give the first two conditions that X is greater or equal 0, Y is greater or equal 0, because we're talking about money. So it doesn't make sense that all X and Y's coordinates will be negative. So how are you going to graph it? So technically to graph all of that, you should graph every single inequality and look for the region of intersection. So if you guys will check the graph, I will leave that for you guys to graph it, but X greater equals 0. So let's just show how to graph that. Hold on. I'm going to see the final scenario. But here, X greater equals 0. So that's that region right here, X greater equals 0. And when they're saying that Y was greater equals 0, so it's right here. So X greater equals 0, you guys will shade like everything above, okay, right here. Now, Y greater equals 0, change it. You will shade everything to the left. So this is Y greater equals 0, so you'll shade everything here. So again, it may look a little nasty right now, but I will erase that. And then here, going back, the next inequality is X plus Y less than equal 25. So they show you how to graph the line X, the pink one, X plus Y here, X plus Y equal 25. So that's the pink one. And they say less than 25 was the inequality. So you will shade everything what is below. So like you guys see so far, here the region, your solution will be where all graphs, regions intersect. And the next one was the last one. We have two more. X is greater equal 15. So let's use green. X greater equal 15. I used the green before. Blue. X greater equal 15. So this is X equal 15. So greater equal 15. So we're shading this. Everything to the right. And the last one here, you have Y less than equal 5. Y less than equal 5. So this is the graph Y equal 5. And they said less than equal 5. So you shade everything below. And I know that my graph looks a little nasty, but technically that's how they end up with this region, okay? That's where all regions intersect. So you see that trapezoid as your solution, okay? And every single point inside that trapezoid will represent all the possible ways how they can invest money. So this is actually very interesting. Again, every single solution. So if you have that point right here, which is part of the solution 15, comma 0, which represents 15,000, comma 0. That's one way to invest. You can have a point, again, the graph is not perfect, but you can just pick any point from the shaded region. That will be the one of the possible way to invest money in those two different accounts. Okay, so that's it from section 12.7. Again, hopefully the lecture will help you to study the material. Thank you for watching.